We're going to do an example of linear programming. This is from your New Late book, page 29. The first thing is to set up three equations. Now, how do you do that? We're going to set up a cement equation, a sand equation, and an aggregate equation. It will pay to note that this cement, sand, and aggregate equals 1 cubic meter. So each of these are therefore decimals. So your cement equation looks like this. We're looking at our two variables smooth, so that's why we've got the S there, and high strength, so we've got the H there. So for sand we've got 0.3 of high strength, of standard rather, and 0.3 of high strength. The most we can have of that is 25.5. We do the same for the aggregate using standard and high strength. Then we go ahead and graph these. Now when S is 0, we work out what H equals by dividing 18 by 0.3 and you get 60. Repeat that for when H is 0 and S is 18 divided by 0.1, 180. Using shading out we get that line, and that area is what we want under the line. Write the equation on the line. Here's the sand equation. Make S equal 0 and work out what H is. And we get 85 for what H is. The same will apply for S because it's also 0. Mark an 85 and do a line down there, shade out and write the equation on the line. Repeating with the aggregate, nothing plus 0.4H equals 48, and then work out what that is. 48 divided by 0.4 is about 120, which is about up there. Do the same for when H is 0. And that gives us a value of 80. So draw your line in between the two green points, shade out, label your line. We can now put in 5 vertices for the area that we want. 4 vertices. I was right first time, 5 vertices. A is producing nothing, 0, 0. B is producing 0 of stack and 60 of hard strength. To work out the actual vertice of C, take the first two equations because it's the blue line and the red line. Using my calculator and then solving, I can find the two coordinates for the vertice. So there's the coordinate for that vertice. D is the green line and the blue line, so we therefore put those two on our calculator. Put the values in, then solve. This gives the vertice 70, 15. E is the point at the bottom, which is the point 80, 0. Anywhere in that region, which I'm going to shade orange, will give us possible values and solutions, but the maximum for profit are going to be at one of the vertices. Now we need a profit equation. How much money will they get? Obviously at A, if they don't make any concrete, they won't get any money. At B, it is nothing for the standard, and it's all hard strength, so they get 240 times 60. At C, put both values in, and working it through on your calculator, they get 19,837.50, which is higher than at B. What about D? Do they get more money doing 70 standard and 15 hard? And when you put it in, they get 19,350, which is not quite as high. So the maximum is at D. Better just check it at E. So there's the combination for E, just 80 times 225 will give you $180,000. Obviously the maximum product will be C, that one there. I shouldn't have used the rubber then, should I? Put your answer in context. 37.5 cubic meters for standard concrete, 47.5 cubic meters for high strength concrete will give you the maximum income. Looking at part C, the increase, we want multiple answers. This is merit to excellent type question. I'm going to attend to that in the next tutorial. And if you have concrete around your garden, you can grow some beautiful dahlias like this one from my garden.